This is Professor Vijayalakshmi. Today I want to discuss about aldol condensation. What is aldol condensation? Condensation reaction of carbonyl compounds is called as aldol condensation. Condensation reaction of carbonyl compounds which are having alpha hydrogens, they are called as aldol condensation. Let us see here. Two carbonyl compounds, may be an aldehyde or a ketone or both aldehydes and ketones, which contain alpha hydrogens. They react to give beta hydroxyaldehydes or beta hydroxyketone, and then when followed by heating, it will give a conjugated enone. I repeat, two carbonyl compounds, for example, two aldehydes or two ketones, whichever, if they are having alpha hydrogens, that means in alpha carbon bearing hydrogen atoms, they will give beta hydroxyaldehydes or beta hydroxyketones. Further, when heated, it will give a conjugated enone. So let us see what is alpha hydrogen. Alpha hydrogens are hydrogens on alpha carbon which are more acidic and because of carbonyl group. So let us see what is alpha carbon. For example, there is a carbonyl, this is a ketone. So this is a carbonyl carbon. To this carbonyl carbon, there are two adjacent carbon atoms. So this is an alpha carbon and this is also an alpha carbon. This one will become beta carbon and this one will become gamma carbon. So now let us see here, this alpha carbon is having hydrogens. Similarly, this alpha carbon is having hydrogens. So such compounds will, either if it is a ketone or aldehyde, they will react to undergo this condensation reaction. So this is very important. That means this alpha carbon should have hydrogens. If they don't have hydrogens, they will not undergo aldol condensation. Now let us see why these alpha hydrogens are very essential. See, if here you observe here this alpha hydrogen, you take beta hydrogen, there is a hydrogen atom here. For example, there is a hydrogen atom here and there is a hydrogen atom here. See, this alpha hydrogen, if you take the pK value of this alpha hydrogen, it will be around 19 to 20. The pK value of this alpha hydrogen is around 19. If you take the pK value of this, it will be around 40 to 50. So this one is more acidic. These alpha hydrogens are more acidic because of the presence of this adjacent carbonyl group. This alpha hydrogen is more acidic because of the presence of carbonyl group. But beta hydrogens are not acidic. See, the pK value is high. So that is why the carbon which is having alpha hydrogens will undergo this kind of aldol reaction. Now let us see what happens here. So two molecules of ketone, for example, now I have taken acetone here, for example. Two molecules of ketone, that means it is having carbon 1, carbon 2, carbon 3. 3 carbons, it is a ketone. In the presence of dilute sodium hydroxide, it will give beta hydroxyketone. This is called as beta hydroxyketone. This is alpha carbon, this is beta carbon. Here you can see there is hydroxyl group. There is hydroxyl group here. So it is called as beta hydroxyketone. Alpha beta carbon is having hydroxy group, so it is called as beta hydroxyketone. Further, when it is heated, water molecule is lost and it is giving conjugated enone. Further, when heated, by the loss of water molecule, it will be converted to conjugated enone. So you can see double bond, single bond, double bond. So there is conjugation. And this is alkene, and this is one. So that is why it is called as enone. So again, I'll explain. Further heating, on heating, it will lose water molecule and it will give rise to enone, conjugated enone. So this is under conjugation, double bond, single bond, double bond. So it is under conjugation. This is ketone and this is alkene, ene. So enone is formed. Now you can observe starting material is 3 carbon but 2 moles. Here we have got both will be condensed and we are getting 6 carbon. 1, 2, 3, 4, 5 and 6 carbon. So this is 6 carbon conjugated enone is the product of condensation of 2 ketone molecules. Now let us see the mechanism. See here, this is acetone CH3 C double bond O CH3. Here for convenience I have taken one hydrogen out. So this is CH3, one hydrogen is taken out. So you can observe this is an alpha carbon, so alpha hydrogen. So the carbon next to this carbonyl compound is alpha carbon which is having a hydrogen. So when you're taking a dilute base, very important. Here the medium should be a dilute base. So hydroxyl group is there. This is a nucleophile. Because it is electron rich, it will donate this electron to this alpha hydrogen. Why? Because this is more acidic. So what happens? This hydroxyl group electron will be donated to this hydrogen. So the bond between the carbon and hydrogen, the bond between this carbon and hydrogen will break. The bond between the carbon and hydrogen will break. So what happens? This hydrogen is lost over here. So now we can see, because this electron is taken up by this carbon, here you can observe this has become a carbanion. The first ketone molecule, this is the first ketone molecule, it has become a carbanion. So I have written as A, first ketone. There are two acetone molecules we have to take. So first molecule has become anion, okay, CH2 minus. Now because it is a nucleophilic again, this is nucleophilic again, carbanion is a good nucleophile. So what happens? It will react with one more molecule of acetone. Here you can observe this is another acetone molecule, that is B. This is B, second acetone molecule. Because this oxygen is electron rich, it will get delta negative charge, then this carbon will get delta positive charge. Okay, by this delta positive charge, this carbanion will attack this electropositive center of this carbonyl carbon. Electropositive center, that is delta positive charge of this carbonyl carbon, this carbanion will attack here. So then what happens? A new bond is formed. Because a new bond is formed, this oxygen will take away these electrons. So here you got enolate ion.